Today is the 22nd of May 2024, and this will be our sixth video on probability, the revision bit. Okay, we've done a lot of probability earlier on, and I said if you're a foundation student, you can use that. Okay, but if you're a higher paper student, maybe I need to clarify some things for you so that you can see and differentiate, okay, when it's being replaced, when it's not being replaced, uh, dependent and independent events, mutually exclusive events, okay, where you have to combine the or and the end law, okay, and then we started introducing the tree diagram with the information we have so that it can help us do the work a lot easier and a bit efficient. I did a bit of tree diagram with you earlier on, so maybe it's good to watch that and then come and watch this, okay, and it will help you understand it a lot. Thank you so much to all my subscribers. Okay, if you haven't subscribed, please subscribe, like, share, and follow. Okay, and when you get the video, like, share, comment, nice comments. Okay, please. If the account is not yours, ask permission from the account holder or open your own account. In the comment section, you normally see, please follow my notes script, okay? Even though I go over my notes over and over again, at times when I'm explaining to you, it's a lot of words and at times it can be mouthful. So at times root 3, especially if you're doing mental math, I might say root 3 and 3, but it's actually root 3 and 3. So please follow the notes, okay? I'll appreciate that a lot. Beware of scammers, please. Beware of scammers. We are not doing videos for any charity, any orphanage, any whatever they have out there. That is not what we are doing. Okay, we are just putting the video out there to help as many people who want this A start to a C grade. Okay, so please follow my note. Beware of scammers. Okay, if somebody gets into your inbox and they're asking you for donation, please, it's not coming from me. Don't fall for it. So I just recapped for you, okay? Watch last video, okay? If you have time, okay, watch last video for recap, okay? And then watch it and sit down and solve a question and then go back and watch it, okay? If you have the time, at this time, I expect that you are managing your time, okay? You are doing time management a lot. So if, for instance, don't leave it to last the day before, but okay, you can do like 10 minutes. And I have tried this several times. At times I'm watching and I have to go off and do something else. When I come back, it's exactly the place I left it. Okay, please. So you can do that. Okay, this technology stuff, I don't know how it works, but that is how it works for me. Okay, not even just my platform. At times I'm watching something somewhere, and then maybe I have to stop and go and do something else. When I come back, it is exactly where I left it. Okay, yeah, it's good to do a lot of education because it helps you. Okay, now I started today again. It says mental mass. Okay, I thought I'll do a lot of this at this time so they can help with your thinking faster, and then with your times table with the square root, it will help you think faster. So you look at the exam question and it's like, oh, I'm stuck here. Then you think, oh, I saw this here, so I can apply this. Okay, because as I always said, immediately you set up the equation, everything else is calculation. Okay, so as long as you arrive the answer and do the necessary step, it's cool. It's not very rigid. Okay, like some other subject, it's not. Okay, now the first one, 2 root 27 times 4 root 8. Okay, 27, you can write it as 9 times 3. So this part here is 2 root 9 times root 3. And then 4 root 8, you can write it as 4 root 8. Okay, now let's look at what we did. Root 9 is 3. So 2 times 3 is 6. Okay, root 9, and then root 3, 4. Root 8 is the same as 4 times 2. So now from here, we have 3 root 3, and then we have 8. Okay, and then we have 4 times 2, which is 8. So root 4, root 2. From there, okay, that is 9 times 3, which is here. That repeats itself. That is 3. So 6, and then we have the 6 times 4 is 24. So we have here. So, and then we have another 2 times 4, which all is under the square root. Root 4 is 2. Okay, so 8 times 3, which is 24, times 2, which is 48. 3 times 2 is 6, so your answer is 48 root 6. You can copy it and see if you arrive at 48 root 6. Okay, this is the simplest form. Now, bracket first, board mass or bead mass. So you can write it as this way, okay, or you can do the bracket and divide by 4 root 3. So 8 times 2 is 16. Root 2, and then root 8, and we'll write it as root 3, root 6. So that is what we have for the numerator. So 8 times 2 is 16. Okay. Root 2, and then root 6, and then root 3. Now this root 3 will cancel this 3 here because we don't want it in the denominator. So the denominator is left with 4. In the numerator, you have 8 times 2, 16. Root 2 is 2. 16 times 2 is 32. Okay, root 3. So you have 32 root 3 divided by 4. Okay, so how many 4s do you have in 32? Okay, so you have 8. So 8 root 3. You can also break it down like I've done it here and cancel out the 2's in the end. Okay, but whatever way you do it, from this one here, you should be able to arrive at the answer here. So you can also copy it out and do it, okay? Um, 3 root 5 times 4 root 8 divided by 2 root 8, okay? So that is our numerator, and that is our denominator. So you have 3 root 5 times 4 root 8 can be written as 4 times root 2. Okay, but you can also cancel the root 8 so that you don't have the square root in the denominator. You remember what I told you? But if you have the square in the denominator, then you have to rationalize. Okay. So you can straight away cancel it, and then you cancel it. So how many 2's do you have in 2? 1. How many 2 do you have in 4? 2. So you have 6 root 5, okay, times 2, which is 6 root 5 here. So from here, this one, you should arrive at 6 root 5. So you can copy this one out, pause, and then solve it and get 6 root 5. Now for 2 root 6 times 5 root 2. Okay, so now 2 times 5 is 10. Okay, root 6 can be written as root 2 times root 3 times root 2. Okay, so root 2 is 2. Okay, root 2 is 2. So 2 times 10 is 20 root 3. So this will be our answer. So again, from here, this one here, your answer should be 20 root 3. And then 2 root 3 times 2 root 3. 2 times 2 is 4. Root 3 is 3. So you have 4 times 3, which is 12. Okay, so again from here, your answer should be 12. Okay. Now, today we are looking at a tree, the tree, okay, with the trunk diagram, non-dependent, okay. So now, example, you have 12 colored cubes in a bag, 5 red, 7 blue. You remove one cube at random from the bag and notice color before replacing it. So here, you remove it, note, you replace, okay. Okay, it's not the non-replacement, and here you replace. That is how it's non-dependent. You choose a second cube at random, okay, and then you replace also. So now we want you to draw a tree diagram of what you just done. So you've replaced twice, you've picked a cube, noted the color, you replace. Unlike the sweets we saw in the other video where you pick and you didn't replace, this one you replace, okay. So this is the first instance. You have 12 cubes, so the probability of choosing a red is 5 out of 12. The probability of choosing a blue is 7 out of 12. Okay, so you choose one and then you note the color, you replace. Okay, because you are replacing, the red doesn't reduce, the overall total also doesn't reduce. So the probability of choosing a red first instance is 5/12. Another red second instance will be 5/12. Okay. The probability of choosing a blue is 7/12. Okay. So first instance here, 5/12 probability of choosing a red, replacing probability of choosing a blue, 7/12 you replace. A red, 5/12 you replace again. A blue, 7/12 you replace. So red and blue. Okay. So what is the probability of a red and a red? Okay. So now you have red and a red. Because it's an end, you are going to use the end law. You are going to multiply. They won't tell you that in the question. You have to look at it and see if it's an end law or an or law. Okay. So that's why I'm doing a lot of examples with you. So you have 5/12 times 5/12 if you are going to choose a red and a red. So which will be 25/144. Okay, there. Now, what is the probability of choosing a red and a blue? So a red first and a blue. So it will be 5/12 times 7/12. You are replacing. So 5/12 times 7/12. You multiply the numerators and multiply the denominators. So it will give you 35 divided by 144. What is the probability of choosing a blue and a red? Okay, so the probability of choosing a blue and a red is 7/12 and 5/12, which will give you 35 out of 144. There, that one here. What is the probability of choosing a blue and a blue? So 7/12 times 7/12. Probability of choosing a blue and a blue, which is 49/144. Okay. Then, so after representing that information on a tree diagram, it's now easy for you to solve any question if you like, especially if you are being asked to. Okay. So now let's look another a tree diagram. You have two coins and tossed. Okay. Represent this on a tree diagram with all the possible outcomes. Okay. So, and use the tree diagram to find the probability of two heads, a head or a tail in any order. So the first instance, the first toss, your coin is either head or tail. If you get a head, it's half. If you get a tail, half. If you toss again, or you can't remove the head and the tail out, you either have a head or tail. Okay. So if you toss again, to get another head, you have half. To get another tail, this will be your second toss. Is half. Okay. To get a head, half. And to get a tail, half. So the question is, how do you get a two heads? So to get a head and a head, okay, will be here half and half. Okay, so if you can draw a tree diagram and you know how to use it, okay, if you are being asked to do a tree diagram, it's good. But if you are not also being asked and you simplify your way, then you can use that to help you uh, get your answer. So head and a head now is half times half, which is 1/4. Head and a tail is half times half, which is 1/4. Head, tail, and a head. So this time first tail, second head is half times half, which is 1/4. Tail and a tail, half and half, okay, which is 1/4 again. Okay. Now the question says, use your tree diagram to find two heads, which is the first line here, head and a head, which is 1/4. Okay. Head and a head is 1/4. It's a tail. Now we have head and a tail in any order. So you can choose head, tail, or tail, head, which is the middle part here. So head, tail, or tail, head. So you choose head and a head, or tail and a head. So you are going to multiply and then you add. Okay. And that is what I've explained here. Half times half, which is 1/4, plus half times half, which is another 1/4. Since you are adding, you add the numerators, the denominators remain the same. Okay, so you now have 2/4, which is 1/2. Okay, there. What is the probability of choosing two head? Okay, head and a head. So if you go to your tree diagram again, okay, you have head first instance, no, tail first instance, and then another tail second instance. So it will be half times half, which is 1/4. So here you have probability of two tails, which is tail and tail, which will be half times half, 1/4. Okay. So what is this thing? It is easier to learn the tree diagram because immediately you can put the information in the question into a tree diagram. Your work is done. So now you can easily look for what you are doing, pick the figures, and then use that to solve the question. Okay. So please, if you've not subscribed already, subscribe. When you get to this video, like, share, um, follow us, okay? Especially wherever you are, platform you are watching from. Okay, help us circulate the platform. If the account is not yours, please ask permission from the account holder. Okay, and then Follow my notes slash script. It's very important. Okay. And just follow the order and my thinking pattern. You might have a different thinking pattern, but we should all arrive at the same answer. Okay. Thank you so much for watching today's video with me, and I'll see you in the next.